This diagram represents is a relativistic wheel. It's not really exactly what you would get from rolling an object near the speed of light, but it kind of demonstrates some of the manifestations of the relativity of simultaneity. And what that means, if I had an ordinary wheel turning at a slow speed, then all of the spokes of the wheel would remain straight. In the relativistic wheel, the top part of the wheel is going near the speed of light, and so a few things happen. These spokes kind of bunch up here as a matter of something called Lorentz contraction, and the spokes at the bottom, basically this comes to a stop when it gets to the bottom of the tire. No part of the wheel ever gets above the speed of light, even though the wheel itself may be moving more than half the speed of light. Now, this turns out to be a surprisingly short piece of code. The mathematics in it is mostly setting up the problem so that Mathematica will solve it. It is, in fact, only one three-dimensional figure. Oh, here's one of the main features of the figure, is a helix shape, and the helix shape is just over time the wheel is spinning, so that wheel is simply basically you take the two dimensions of the x and y axis and then allow time to progress forward, and you get this graph if you do a 3D plot of it, of the x, y, and t coordinates. And then we slant that those coordinates using the Lorentz transformation. And wait, that didn't come out show right. There we go. Let's come do that again. So here it is stationary, and as you slant it, this is what it would appear if you were going by it or it was going by you. So it still does the swirl, but this time you're going to see it from the side. And you do the same thing with the cylindrical shape. Just open it, just basically make a straight cylinder and then slant it. Now if I were to rewrite this program today, I would probably do some things like try to separate these things out into their own defined functions so that it's not all pushed together. So for instance, this parametric plot 3D is doing graphs of several different things. This one is a function of r and theta, and so it's creating a surface along r and theta. This part is going to be another two-dimensional surface with varying r and theta, and this one is a third two-dimensional surface with varying r and theta. So what are these? I think they vary. You have theta minus theta n and theta minus theta n. You got theta, and you got theta minus 2 theta n. So what's going on here is that this is producing the 6 spokes of the wheel. Let's just grab this one without any theta n in it for the moment, and we'll have a look at the matrix form of it, so it comes out maybe a little simpler, and see if we can't reverse engineer where this came from. Now this vector, as we vary r from -1 to 1 and vary theta from what was it, negative 4 pi to pi? To 4 pi. Yes, we had theta going from negative 4 pi to 4 pi. Evidently, this thing produces a slanted helix. As a matter of fact, let's go ahead and see that slanted helix without all of the other material in the program. Oh my, it's quite large. So this is the slanted helix that is produced at the beginning of the program, and it appears to produce a slanted helix that goes all the way from t equals like negative 30 to positive 30. So if I were to reverse engineer this thing, I know that we started with a vertical helix and we applied a Lorentz boost to the thing. I can also tell that the Lorentz boost is not doing anything to the central object there because of the r sine theta. So it's doing cosh negative sinh and negative sinh and cosh to something over here. But what is that something? Looks like the cosh phi was multiplied by r cosine theta, and the negative sinh was applied to theta over omega. And finally, the 1 was applied to just r sine theta. Now that's interesting. That's a very simple formula, it seems. If you let r go from negative 1 to positive 1, then each r basically produces a line along angle theta, and then the z, but the theta is changing, so as you go up with each successive level of the z-axis, as you increase that, theta goes up, so each time you get a new line along that direction. So that's a fairly elegant way of producing a helix with a parametric plot. That's interesting. I can compare that to my first attempt to produce this image, where instead of using r and theta as my variables, I tried to use x and t. So I had x going from negative 3 to 3 and t going from negative 0 to 10, and I tried to find y by taking basically doing some trig x tangent omega t plus theta n, and this is what I ended up with. There was an image that is a little bit harder to tell what's going on. It's got the, I think I must have decided to remove the kind of grid marks on the thing because they weren't very helpful. I forget exactly what they look like. But there was an issue with this that I had to remove one section of the thing because tangent of, well, actually exclusions, anytime that the cosine of the angle was 0, then the tangent of the angle was undefined. So it created a strange phenomenon right around there in the graph. So I had to cut away part of that graph to use the x and t variables. And I think it may have been a couple of days before I thought, wait a second, I could make this much simpler, and it came out much nicer looking when I just went with parametric plot using r and theta as my variables. And here's when I first started realizing what I wanted to do with what I was going to do. Instead of really trying to graph each individual section, I would just create that three-dimensional graph and only show you one plane of the diagram all the way up. And so the spinning is a result of just showing you that single plane. And there's only one really bothersome issue in the final result is these negative signs that pop up. Because when the negative signs pop up, they cause the entire figure to jump. And all those negative signs are doing are just showing you where you are in time. As a matter of fact, not only that, they're going backwards in time. That's because I had the slant going one way, and I think I ended up having, I had everything slanted in the wrong direction regarding the rotational motion. So here, instead of having the time increment in a positive direction, I had the time incrementing in the negative direction. Probably a more elegant way of solving that would have been to define omega going the opposite direction, because that would have turned the angle of rotation to be in the opposite direction. So let me make that change the code. I'll put that at a negative 0.9, and I'll change this to a positive 0.2 just to make it a little bit. I think it'll start going the opposite direction. It'll move to the left instead of to the right. And then what else do I want to change? Glancing down through the help on parametric plot 3D, I see this one has no coordinates on the side, so let's use, looks like it says axes gets none. And which one gets plotted first? It says, shoot, where was that? Here it is. It says show P2, P1, P3. So really all I have to do is change the definition of P2. So I will add axes none right there. Okay, the bad news is when you start saying C equals C plus 0.2 instead of C equals C minus 0.2 inside a while loop that says C is greater than negative 2.5, it does not work properly. So let's start with C equals negative 2.5 and let it go to while C is less than 2.5. Try that one. Okay, and something a little bit surreal happened. We actually do have a correct form of motion, except for the fact that the sense of rolling appears to be it's rolling on the ceiling rather than rolling on the floor. So so instead of changing omega, let's put that back to 0.9 and change phi to -1 and see what happens then. What should happen is the rotation will go back the way it was. That's not staying down there. Okay, it's doing these, it's counting, but the rotation will stay the way it was, but the slant will be the opposite direction, and that way sadly no, this also did not work quite right. It looks again like the rotation is appropriate, but for some reason it is still on the ceiling. Maybe the idea of changing two things. I think I get it. These equations r cosine theta and r sine theta come from the assumption that the thing is rotating counterclockwise with increasing theta. So let me try one more trick of changing the sense of how theta goes. We'll have it go from 4 pi. I'm not even sure if that actually works. Video, because goodness gracious, I think it failed. So I think I'm going to have to leave this for now. Usually what happens when a video is made too long is that the sound gets removed from the video,